paper, the first talk by Santiago. Please, I'm losing my voice due to bad cold, so I'm going to do your own.
All right, thank you. Yeah, so hi everyone, thank you for being here. I'm Santiago and I'll be talking about a new platform for application development. And this is joint work with my advisor, Daniel Jackson, and with 3 master's students who have since graduated, Maya Marchi, Serena Lau, and Barry McNamara III. The premise of this work is that most apps are fundamentally very similar to each other, in the sense that most of what they're doing is combining pre-existing concepts in new ways. So let me give you some examples to illustrate this point. Here are screenshots of 4 popular websites: Twitter, Hacker News, The Wall Street Journal, and Facebook. And at first, it might seem that they are different. They have a different purpose. They look different. But if you focus on the concepts, you'll see how much behavior they share, how much in common they have. And by concept, I mean something you need to understand in order to use the application. So for example, in all of these apps, you can comment on things. On Twitter, you comment on tweets, what they call a reply. On Hacker News, you comment on posts. The Wall Street Journal, you comment on articles. And on Facebook, you comment on posts. And in all of these cases, you can also comment on comments and so on. You can like things in all of them. You can register users with a username, password, and so on. And while developers in all of these 4 cases are reusing some code, for example, they might be using the same front-end framework or the same libraries for implementing authentication server-side, they are, for the most part, however, implementing each concept from scratch. And the problem is that we're wasting time constantly re-implementing and redesigning these concepts. And by doing so, we're introducing errors. So you might think, well, who's going to get the like concept wrong? It's not that hard. But consider this example. Shopping carts are everywhere. Okay? This is a screenshot of a shopping cart on the Adidas website. And it turns out that if you try to set the quantity to 0, you'll get an error saying quantity cannot be 0 instead of doing what you expect it to do, that is to delete the item from the cart. I guess they probably fixed it by now. But note how even getting common concepts like that of a shopping cart is challenging because there's lots of details that you need to be aware of and properly account for. Now let's talk about web development. At MIT, we teach an undergraduate class in web development, which is pretty similar to what you can find in other universities. And it covers all the topics you need to know if you want to develop web applications with rich behavior. So you have HTML, CSS, JavaScript, all these things, all these more things, and many more things. OK. And now they're web developers. So after all of that, we ask them to do a final project. Okay? And students can choose to do whatever they want. These are the final projects the students built in fall 2018. And they are actually all over the place when it comes to their functionality. You have, for example, a team built a tool for supporting musical bands in the selection of set lists. Another team built a tool for assigning chores to children, an app for planning events on campus, and so on. And even though all these apps are very different in some sense, if you look at these projects, you'll see that they share still lots of concepts. For example, you can rate things in many of these. In one case, you're rating songs. In another case, you're rating users. In another case, you're rating campus spots. Event, you have like some cases events are parties. In other cases, events are different kinds of parties. One is a potluck party, and the other one is a party in campus. Or task. Sometimes a task is a climb you need to complete as part of a climbing competition, or a chore for your children to complete. So we saw an opportunity to develop a new programming model that enables concept reuse and the simple assembly of web apps from predefined concepts. The goal here being to reduce the amount of knowledge and effort required to build web applications and to allow end users to build more sophisticated apps themselves. Our platform, called Dejavu, lets users combine concepts like post, comment, rating, and so on to build web apps with rich graphical user interfaces. And to build apps in Dejavu, users write HTML. No JavaScript or server-side code is required. And as we'll see later, you can synchronize actions to compose behavior. There are 4 key ideas in our approach. The first is concepts as modules. So concepts are the building blocks of deja vu applications. They are self-contained. They are a self-contained reusable increment of functionality that is motivated by an end user purpose. And they export a set of components. And components in deja vu are pretty similar to components in React or Angular. So they are a GUI element. They have input-output properties and so on. A key distinction, however, is that our components cannot make an arbitrary request to an API. They actually have an associated server-side action. And there's one server-side action per component. Concepts are full stack. They include both front-end and back-end functionality, and they have their own database. Each concept instance is completely independent from each other. A concept instance cannot communicate with other instances or share any data. Abstractly, a concept instance is a state machine that changes state only in response to actions issued by the user to the front-end components of that instance. So, for example, a user might interact with a create post component. It might click on the create post button, and that might trigger the execution of the server-side action of that component. And as a result, it might say, save a new post in the database, for example. What triggers this server-side action is up to the author of the concept. It might be usually some kind of like user interaction, such as clicking a button, selecting something from a dropdown, or so on. So now, let's say I want to create an app, okay? And I want users to create posts with an initial score. So I create a submit post component, add the post concept to my app, and add the create post component to my submit post component. So now I have posting functionality. We add scoring and create score, okay? And now users will be able to, by interacting with create post, create new posts, and by interacting with create score, create new scores. But so far we have posting and scoring functionality, but they're completely separate, right? If we want to create posts and scores, we need to compose the behavior of create post and create score. So in Deja Vu, this is done with two things. One is synchronizing concept actions and sharing IDs. So let me talk first about synchronizing concept actions. If you want the actions of a component to be synchronized, you can wrap them in a transaction, okay? Then when some concept attempts to run its server-side action, for example, because the user interacted with a create post component, all of the other components in the transaction will also run their server-side action together. Moreover, action synchronization is transactional, ensuring that either all of the concept server-side actions occur or none of them occur. So, for example, if one server-side action chooses to fail the transaction, because, for example, the score is negative and maybe scoring doesn't like negative scores, then the score and the post will not be created. Okay? So this same mechanism can be used for authentication. Our platform has no built-in notion of authentication. These are concepts just like any other concept, so we have an authentication concept. And if we, for example, want to authenticate the post submission, we can include the authentication concept and add the authenticate component to our submit post. And the authenticate component will authenticate the logged in user. So now if the user interacts with the create post and the user is not logged in, the authenticate component will fail the transaction and the post will not be created. Finally, we need to associate the score with the post being created. Okay, so let's go back to our example. We have create post and create score. And this is done by sharing IDs. Okay, so our platform has a built-in component GenID, and we can that will generate a unique ID, and we can then wire that ID output as an input to create post and create score. As a result, create post will use the given ID as the ID of the new post, and create score will use the given ID as the target ID of the new score. Much like a foreign key in a relational database, our post and score are now linked implicitly by the fact that they share the same ID. Now let's see what this looks like in practice. So I'm going to show you how you would implement a simple app called Slacker News, which is that is a simple clone of Hacker News. And for Slacker News, we're going to use the authentication concept to handle user registration and login, post to deal with posts, comments, and scoring twice, once for keeping track of post points and the other one for comments. So this is what Slacker News looks like. Users can register with a username, and they can submit a post. You cannot upvote your own posts, but another user, for example, Alice, could come in, register, upvote the post, and maybe leave a comment. Okay. And you can comment on comments, and you get the normal nested view and so on. Okay, so how would you build this using Declarative? The first step to build an app is to find the concepts we need. So this is what our catalog of concepts looks like. And for Slacker News, we use these concepts. Now, you might have thought that there should be a post concept, but instead, we could have a post concept, but instead, we're actually going to use property, which gives us a data model defining facility for simple create, update, delete behavior. And we can use property in this case because our posts actually, they don't have any behavior. They're sort of like, they don't have any behavior beyond simple crude behavior. So the concepts used by the app are specified in the app's JSON config file. The use concept objects has one key value pair per concept instance. The key, for example, post, determines the name that is going to be used in the HTML to refer to that instance. And the value is another object with two key value pairs, name for providing the concept that to be instantiated, in this case property, and config for configuring that instance. For Slacker News, we only have to configure property. So property accepts a configuration variable schema that expects a JSON schema to describe the object that we'll be saving. So we're sort of like saying here, okay, we have our objects are posts, and they're going to have an author, title, and URL, and these fields are required, and so on. And the effect of doing so is that when we include a component from property, it will, for example, create object, it will ask the user to input those fields. Finally, we can specify the routes of the web app. Each route maps a URL path to a component, and the home component is the home page because path is empty. So this is what an app component looks like. On the top, we see an excerpt for the code for submit post. Our template language looks, by design, very similar to other template languages. Components are included as if they were HTML elements with a tag given by the concept instance or app name, followed by the component name. The screenshot below shows how each of these components appear to the user. Some components, like GenID, for example, don't have a visual representation. And for those that do have a visual representation and you don't want them to show up for some reason, you can hide them with this hidden property. This hidden property indicates that the component should be hidden, but it should still be activated. And we hide create score in Slacker News because we don't actually want the user to be giving us a score, but we do want to initialize the post with a score of 0, sort of like, so that it has some sort of initial score. The dbtx tag indicates that these components should be synchronized and executing a transaction. And we use dbGenID to generate a unique ID and wire the and we use the ID. We wire the ID to the ID input of create object and the target ID input of create score. So now, when a user clicks on the submit button, the create post component will trigger the execution of its server-side action. And because it is wrapped in a transaction, both the server-side action of create post and create score will run at the same time. And we're going to end up with both a post and a score connected with the shared IDs. So this is an excerpt of the code for show post. Here we load the post using an ID input that is provided as input to the component. And we use the loaded post information in several parts of the view to display the URL, the title, the author, and so on. So in summary, to build apps in Dejavu, you choose concepts from the catalog, you include and configure them in JSON, and then you create components by including concept components, and whenever you need them to do things together, to compose them, you synchronize them and bind the IDs. So I'm going to tell you a bit about the implementation of the platform. Our runtime system consists of a client-side library and a gateway. Concept components do not communicate with our servers directly. All communication happens through our front-end library, which takes care of mediating all these run events and sending requests to the gateway. The gateway processes requests, and depending on whether the action is a transaction or not, it will initiate a two-phase commit with it might initiate a two-phase commit with a concept service if it isn't a transaction. So the fact that all communication goes through the gateway is important for security, because clients cannot be trusted, right? So a malicious client could, for example, attempt to execute an action that is not part of the application, or attempt to violate the structure of transactions with the goal of, say, reading some private information and so on. To prevent this, the gateway receives the source code of the running app when it starts. And this allows the gateway to know what actions could be executed and what is the expected structure of each transaction. In some sense, it knows what the space of allowable request is. And as a result, it can block malicious requests. So to evaluate Dejavu, one of the things we did is to compare it with a standard approach to web development. So let's consider a very simple example where we have a component that lets users create posts with ratings. Okay? Something like, for example, what you can find on this student app, but we're going to ignore all the other map stuff going on just to keep it simple. So this is the code for submit post in React, which is a popular web library. And for the server-side code, we consider two alternatives, as a monolith and using microservices. And for the purpose of this comparison between the standard approach of web development and Dejavu, which I'm going to show you afterwards, we're going to assume that all the posting and rating functionality is given. Okay? But even if we assume that all of that functionality is given, in the standard approach, there's still lots of things, there's still very complicated glue code that we need to write. Okay? We need to subscribe to events. We need to write event handlers. And the event handlers for the form submission need to aggregate the form data to send a request. For the server side, in both cases, we need to validate the request, and we need to save the post to the database in the case of the monolith, or integrate the microservice, or integrate the microservices in the case of the microservice architecture. On the other hand, when using Dejavu, none of this is necessary. So this is what the same component would look like in Dejavu, where we assume we have the property and rating concepts. So in Dejavu, we wrap the components in a transaction and bind the IDs. And as a result, Dejavu will automatically do all these things for you, such as subscribing to events, sending requests, maybe starting a two-phase commit, and so on. Well, in this case, it definitely will. A question we were interested in answering is it possible to build a variety of non-trivial applications using Dejavu? So remember the student projects I mentioned before. We actually replicated, we used Dejavu to replicate the core functionality. So these are all our clones. And one of the things we looked at is how the apps we build use the concept catalog. So these are concepts in our catalog that are used in the app. These are the set of app clones. And each square represents the number of times that particular concept is used in that app. Most apps use roughly the same number of concept instances, and this is probably because all the student projects we replicated sort of like took a similar amount of person-hours of work to develop, and are therefore roughly equivalent in terms of complexity. Authentication, authorization, and property are the most used concepts, which is not surprising since most applications require to register users and so on. And they also have, it's very common to need to store domain-specific fields like user profiles and posts and stuff like that, and you can use property for that. Some concepts are only used once, but we do not think it is because these concepts are too application-specific. Chat, follow, match, ranking, schedule. These are concepts that you can find in popular apps. Follow, for example, implements functionality that is very common in social media applications, like in Twitter. You can follow other accounts, and you get their tweets in your feed and so on. One thing we discovered is that non-trivial behavior that might at first seem like it would require the implementation of a very specific concept can often be implemented by combining existing concepts. For example, let me show you a bit of ChoreStar, one of the apps we replicated. And this app has an interesting behavior. There are two kinds of users, parents and children. Children cannot create accounts directly. Parents must create an account for children, and then once the account is created, then children can log in. This relatively uncommon feature was easy to implement in Dejavu. We included authentication twice, one instance for parent accounts and the other instance for children accounts. And we included, when we're in the parent home, we included the register user component for children, the authenticate component for the parent, and synchronize them. So as a result, only parents can create children accounts. So to conclude, I want to first take a step back. And let's say you want to build a simple web application, something like what I've shown you, like Slack and News, for example. Today, you have several options to do so. You can choose to use general purpose tools, which are very flexible. You can build any web app with them. But the libraries and frameworks are often just client or server side. So even if some of the functionality you need is already available, you still need to write a bunch of glue code to, for example, process requests and so on. And note, by the way, that even if you use like a full stack component, such as like Discuss for comments or Stripe for payments, you usually still need to write server-side code to integrate it to the rest of your app. For example, you might need to create a notification hook so that your app is notified when a new comment is created, so that it is given an initial score, something like that. You can use a content management system. The nice thing about content management systems is that they have lots of plugins. And with plugins, you can include a lot of functionality into your app very easily. But plugins can only be combined in certain ways, and application-specific combinations typically require modifying server-side code. You can use one of the many low-code development platforms and tools, and these tools typically offer a visual interface for specifying a schema, query updates, and views, and so on. But you still have to write most of the end-user behavior yourself. Our Dejavu platform gives you another option. Like plugins in content management systems, our concepts are full stack, but our concepts are more granular, and also they have a generic composition mechanism, which you can use to put them together. So any concept can be made to work with another one, no matter whether the original author thought about that integration or not. And you can build complex apps in HTML. So one last thing I want to mention, since it might be of interest to some of you in the audience, is that we've been developing a graphical programming environment for building Dejavu apps, which was Barry's master's thesis. And in this environment, you can graphically import and configure concepts, build components with drag and drop, and you can interact with the app as you develop it. So thank you. On the web page, you'll find links to our GitHub repo that has the code for the tool, a video about the programming environment, and a bunch of other things. Thanks.
So, questions?
Hi, Santiago. Nice work. I may have missed this, but when you're composing the UI of the components, it looked a lot like there's sort of web components that are distinct rectangular regions on the screen, yet a true concept, might be up here in many places on the screen, right? It's an aspect of it. How do you deal with merging the UIs of these concepts?
So basically, you would have to include each component of that concept. Like, we don't have an automatic way of sort of like mixing in all this behavior. Essentially, you would have to sort of like choose the concepts you need from that concept and put them in the page yourself with HTML.
But if there's like, a little checkbox inside the UI of another component,
so the way that's handled is that our components are higher order, so they can take another component as input. And so if that component, if you want to put something next to a checkbox, that component might be taking some component as input that you can replace so that it appears next to that checkbox.
Thanks.
Thanks. Yeah, that seemed like a really nice design. When I was young, we had things called widgets, and we built rich client applications out of them. And sometimes there'd be a declarative kind of glue for describing a sort of arrangement of widgets on the screen. And we used object-oriented programming to sort of wire everything together and so on. So can you say anything about how the programming model compares between that style and what you've built?
So I think the key thing is the way you compose these things. So the fact that you just say, I want to synchronize these two components. And just by wrapping that thing in a DBTX, you sort of like get that. And the binding of IDs. So you never like, if you have any specific like tool in mind, let me know and I can sort of like look into it. But from what I've seen in most other widget sort of like system, you're always ending up doing things like, when this button clicks, I'm going to call this thing and then call this other thing and so on. And this has a nice thing that you don't do that. You sort of just put them on the page, synchronize them, and then that's sort of like how you get the component behavior.
Okay, I might pick your brain later about some of that stuff. Thanks.
Yeah.
If I don't find the component I need in the library, what should I do?
So, good question. So basically, if you don't find the component in the library, you need to build it yourself. And the way you do that is, so by writing, like, it's sort of like building a normal web app kind of sort of thing. Like you build a back end and a front end. Our goal is to make it sort of like, two goals there. One is to make it as easy as possible in the sense of not making it much harder than developing a normal web app. So there are a few things there. So for example, our concepts need to implement the two-phase commit protocol, right? So that's sort of like a thing that if you're building a normal web app, you probably don't need to do. So we built like a bunch of libraries and tooling to sort of like help bring that down, and so that it's more like building a normal web application. And then the other thing is that we try to be as agnostic as possible as to what technologies you want to use to build your concepts. So for the server backend, we're almost there because we just sort of like interact via HTTP, so you could probably sort of like use whatever language you want. For the front end, our prototype implementation is written using Angular, so right now you have to use Angular, but hopefully in the future you'll be able to use like React or something else.
I'm curious if you do any optimization across components. If you put, 15 components on a page that, go and get multiple levels of data, does it optimize queries across components and things like that?
Good question. So, let's see. So, it is doing some optimization in the sense that when something triggers a server-side action, and we know that it's in a transaction, then we only send one request. We sort of like aggregate all the requests of all the individual components and just send one transaction request server-side. So in some sense, that's you can almost think of it as an optimization. On the other hand, however, if the components are not in a transaction, then you will get like a ton of requests going everywhere, and that's something that we sort of like haven't explored yet.
Thanks for the talk. It's a really nice platform. So I was curious, how does styling look like in your template language? Because I noticed you're using the dot notation for actually assigning semantics to the components.
How does what work? Sorry.
How does styling work?
Oh,
how can I assign
yeah.
classes, let's say?
So you use CSS for styling. So since it's normal HTML, you just use CSS for styling your HTML. And we sort of like, sometimes you need to style something that is inside a concept component. So what we do, for now at least, is that all these concept components, they sort of like, they might add a CSS class to some HTML element. and they might call it like authentication registered user or something, whatever. And you can sort of like style it from the outside that way, because you just sort of like use that class and provide some style for that class, just using normal CSS essentially.
Okay, thanks.
Thank you.